is we would look through that one, and I'll probably have you, after we do some of the skills for a couple of weeks, have you take the FIAB as a practice, just to get used to the system that you're going to be in for SBAC, and that we're actually showing, hey, we're trying to put some effort in. Trying to save the harder ones, or the ones that we need like the most reminders on, like the statistics and some of the other, there's some weird geometry that we haven't probably seen in a long, long time. I'm trying to save those for closer to next semester, for closer to April when we take it. All right, so we're going to talk angle of elevation, angle of depression. We did this last year, so I'm not doing like a full note set. I'm doing the basics here. This is the refresher. Draw yourself a nice little diagonal line, because I was really lazy. I only draw parallel lines, okay? All right, you're on the ground floor. You get in an elevator. Which direction do you go? Up, okay? So the up angle is your angle of elevation. And remember, on angle of elevation, angle of depression, it's up or down from a horizontal line, okay? You're sad, you're depressed, or you are, what's another word for that? Down, we're down. Okay, so the down angle, okay, is the angle of depression. Okay. You got to be careful. A lot of times we're working with a right triangle on angle of depression, and it's not that angle right there. Okay, so it's not that one. All right, it's only the one from the horizontal. The nice thing about this is if you have the angle of depression, you also have the angle of elevation, because if we have parallel lines, we learned that, the alternate interior angles are congruent or equal. Okay, so we know that those two things are exactly the same. Okay, all right, so let's talk about Brian. Brian's kite is flying above a field at the end of a 65-meter string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? Okay, so I've got to draw a picture. I'll draw Brian. Okay. And I usually will attach the kite from the ground because it makes the triangle nicer. Okay. So we're going to assume it's from the ground if they didn't give us any other like indication of what it was. Okay. All right. So there's my little kite. We've got a height. We've got the ground. You're looking for a right triangle. Okay. I'm going to read through again and do some labeling. So Brian's kite is flying above the field at the end of a 65-meter string. So that's the 65-meter string. If the angle of elevation to the kite measures 70 degrees, so that's my up angle from a horizontal, 70 degrees. How high is the kite above Brian's head? That's a little bit deceiving. Technically above Brian's head would be here. We're going to assume is that they're looking for that angle right there. Okay, so we're going to call it this one is what we're looking for. As technically they're parallel. They didn't tell us exactly how tall Brian was, so we're going to go with what we've got there. Okay. All right. We got to remember the parts of a right triangle when we're doing trig. You all know this. Okay. When we are across from the 90, what part is that? Good, hypotenuse. When we are across from the reference angle, what do we call that? I think I heard it, opposite, right? And then what's the other one? I don't need it this time, but what's the other one? Adjacent. Okay, so we're back in the SOHCAHTOA world of trig right now, okay? Not the unit circle world, all right? This also means when we do our calculation, our calculators should be in degrees, not radians. So make sure when you're doing like SBAC like things, because they have the Desmos calculator built in, make sure I think it defaults to degrees there. On regular Desmos, it defaults to radians. So just be careful. All right, I have opposite and hypotenuse. So which trig ratio do I have? Sine. Okay, so I'm going to go sine of how many degrees? 70 equals, what's on my opposite? X. What's on my hypotenuse? Good. If we only wish the algebra was this simple last week, right? I promise today and tomorrow, and then it gets way better Wednesday. Okay. All right. What am I going to do with this 65? Multiply. So 65 times sine of 70. You don't have to write the degree symbol if you don't want. Okay, so I'm going to go, everybody open Desmos, because you have to be able to do this on your own, right? Not Mrs. Ballard doing it for you. I'm going to do it with you today, but you have to be able to do it on your own. Okay, so I'm going to get Desmos tab open. Okay, first thing I'm going to do is I'm going to come over to little wrench, and I'm going to switch it to degree mode, so I have the right calculation, okay? All right, and then we had to do 65 times sine of 70. So 61, and we're going to go 3 decimal places just because that's what we do for calculus. We're in that habit. 0.080. So 61.080, and the measurement was labeled in meters. It should be familiar. We did a kite problem or two last year. Okay. Okay. Let's take a look at one more. Okay. So I want you to look at number 2. Read it to yourself really quick. After you read it to yourself, I'll give you 1 full minute. Read it to yourself and try to draw the picture. Okay, let's go through it together. So from an airplane at an altitude of 1,200 meters, okay, so I'm drawing my airplane. I know that its altitude is 1,200 meters. The angle of depression to a building on the ground, okay, so there's my building. Remember, my angle of depression comes down from my horizontal, so it's that angle right there, which is kind of outside the triangle right now. It's 28 degrees. Find the distance from the plane to the building. They're asking us for that distance right there. Okay. I'm going to complete my triangle. I know that angle of that angle of depression is 28 degrees, but I also know that this angle of elevation is also 28 degrees. So I'm going to move it down to the bottom. We know they're one and the same. Okay. What part of the triangle is the X? It's across from the 90. What part is it? Hypotenuse. Good. What part is across from the 28 degrees or the 1,200 there? Opposite. So when I have opposite and hypotenuse, what do I have? Which trig ratio? Sine. Good. Sine of 28 degrees equals, what am I going to put? What over what this time? Yeah, this time it's 1,200 over X. So what's different about this one compared to the last one? Yeah, the numbers in the numerator and the X's on the denominator. So the way you calculate is there's an extra step to your calculation. Okay. I'm actually glad it kind of came up like that. I know you could all, if we had an adjacent, you would call it cosine. If you had an opposite and adjacent, you would call it tangent. I'm confident if that popped up on a quiz, you guys would be fine. They both happen to be sine examples today. So it is what it is. All right. What do I have to do to move that X to the other side? Right now it's under division. How do I move to the other side? Multiplication. Good. So X sine of 28 equals 1,200. Remember, sine of 28 is a number. It's a decimal point number. That's an equal sign. I don't know what it looks like, but it's not an equal sign. All right. How do I move that sine of 28 to the opposite side? Divide. So X equals 1,200 divided by the sine of 28. All right. I want you to try to put that in Desmos. It's going to be a big number, and that's okay. It should be bigger than what we have because 90 is there. The hypotenuse should be the longest part of the triangle. Okay, so everybody take a minute and try to get it into Desmos on your own before I do it with you. All right, that's what I got. 1,200 divided by sine of 28. Everybody with 2,556.065. And I'm okay if you just chop it off like we do in calculus, even though I know we're doing an SBAC thing right now. It was 2,556.065. Okay, and this was still in meters. Okay, so whatever the label is, it goes to that label. Okay. All right. I am going to, so the next place I need you guys to go is I want you to go into Otis. So everybody go into Otis. I'll show you what I want.